metal industry is on the brink of a major upheaval, with millions of jobs worldwide at risk, as Voestalpine's special steel plant in Kapfenberg has just introduced cutting-edge machines that can do the work of hundreds in mere minutes.
This investment also serves to secure the long-term future of the Styrian sites in the high-performance metals division.
Next-generation 3D metal printers are set to render traditional forging houses obsolete and other mind-blowing machines. But just how advanced is this factory? And what does it mean for the future of the industry?
With more than 3,000 highly qualified employees working in Kapfenberg and other 500 in Mills-Zuschlag.
Join us in this special episode as we uncover the looming threat to the labor force posed by this revolutionary metal factory, the workplace of the future. In the fall of 2023, Voestalpine created the world's most advanced workplace when it opened the world's most specialized steel plant. It was like the predictions of the legendary business heroes were coming to pass right before our very eyes. Was it a mistake to let technology advance at this rate? What happens if these special plants spring up in many places around the world? For big manufacturers, Voestalpine was the goal. It was very beneficial to them. The plant met the most advanced Industry 4.0 standards and thrived on the interplay between tradition and modernity. This was where decades of engineering expertise met cutting-edge technology. It was crucial for recording a technological milestone. Steel production has completely moved from analog to digital D&D, and you begin to wonder if there will be a need for humans in the world soon. Procedures, working methods, systems, processes, control, collaboration a lot had changed at the new Kapfenberg special steel plant. Although digitization came with its challenges, the use of robots and manipulators meant less physical effort. The training of tomorrow's generation of skilled workers at the modern training center in Kapfenberg focuses on the digital workplace. But how many workers can be employed? The new plant, which the company claims is the world's most advanced in terms of digitalization and sustainability, is the first of its type to be constructed in Europe in 4 decades. Once fully operational, it will have the capacity to produce 205,000 tons of special steel annually for highly sophisticated customer segments. In the new plant, all the melting processes are directed from a central control station. There are no branches to accommodate more employees. The workers are trained in robotics, sensors, and data analysis at the company's on-site digitalization competence center. The Voestalpine Group's high-performance metals division focuses on producing and processing high-performance materials and customer-specific services such as heat treatment, high-tech surface treatments, and additive manufacturing processes, increasingly using digital technologies. The division is a market leader for tool steel and high-speed steels, valve steels, as well as other products made of special steels, powder materials, nickel-based alloys, titanium, and components, some of which are produced using additive manufacturing technologies. The division has set itself the goal of making sustainability integral to every aspect of its work. Its most important customer segments are the automotive supplier industry, oil and gas exploration, mechanical engineering industry, consumer goods, and aerospace industries. With the high-tech plant, it will be possible to fully automate the production of tool steels and special steels for the most sophisticated applications. They are the starting materials for processing into extremely high load-bearing and weight-saving aircraft parts, robust tools for the automotive industry, equipment for the demanding conditions of oil and gas exploration, and for manufacturing components using 3D printing. Another highlight of the new special steel plant lies in its environmentally friendly and sustainable steel production. Heat will be released from the smelters to the district heating system. Cooling takes place via a closed loop, and the plant operates extremely efficiently. At the heart of the plant is the electric arc furnace, which will be operated using only green electricity. While technology is great, you can't help but feel anxious at the possibility that businesses may not need humans to thrive again, since everything is being replaced with technology. Many high-end tech companies have laid off thousands of workers to cut costs and maximize profit. Let's not forget the immense pressure it puts on other business owners who cannot afford to fully digitize their workplace. Voestalpine reportedly spent about 300 million euros to build the new plant. How many manufacturing businesses can afford that now? Not everyone would understand new trends in technology. And if everyone understood, the manufacturer would still pick a few voids to handle field control. What happens to the rest? Some companies have incorporated the complete use of technology into their systems, including robots to replace all humans on the field. What is left is the administrative control. How long do we have before another technology takes that away? Technology is great, but it may not be favorable when it comes to securing lives in the future. Let's talk a little about the metal production industry. The metal production industry would continue to thrive because it is directly linked to technology. There is still more to do in various industries across the globe that require metalwork and manufacturing. For instance, the major factor in the medical industry is precision. Surgical instruments like clamps, forceps, and scalpels are all the results of complex metalworking processes. Many types of medical equipment must be manufactured with extreme precision because it directly impacts their effectiveness in saving lives and improving patient outcomes. A poorly made component can cause equipment to malfunction. In a healthcare situation, this can mean the difference between life and death. In the automotive industry, simply put, automobiles would not exist without metal stamping technology. From the inception of the automobile industry to its modern state, metal fabrication has played a significant part in the vehicles that we all drive around. Car customization and modification have been significant aspects of car culture since cars became widely available for consumers to purchase. If a customer wants his car to be different from the rest, he goes to an engineer for modifications. Whether it's a slight modification, such as adding a spoiler, adding body skirts, or a total body rehaul, metal fabrication is essential to the process of any car's body modification. In Voestalpine, every product fabricated from metalworking has its use for someone in society. Here are some of the most advanced machines used in their production. The highly specialized stator winding machine. Only a few industrial companies can host this kind of machine given its advanced nature and cost. The highly specialized stator winding machine is designed to wind copper aluminum wire of any kind around the stator core with unbelievable accuracy. It saves time because you don't even have to check if your windings are placed correctly. You are almost certain that they are. The stator winding machine is used in the production of electric motor stators. When these wire windings are placed correctly, the electric motor's performance and durability are optimized because there are no defects. The highly specialized stator winding machine found in Voestalpine can take on more complex winding patterns. It is usually controlled by a computer numerical control to enable automatic and repeatable winding processes. The computer numerical control takes record of important parameters like wire tension, winding speed, and the number of turns to ensure that the windings are accurate across the board. This means that if a client needs 1,000 electric motor stators with an exact specification, that's what they get. Before the invention of this specialized stator winding machine, many electromagnetic and mechanical manufacturers practiced the formed coil winding for accuracy. They shaped the wire into a specific coil before inserting it into the stator slots. Although they got a fairly accurate wind, the process was costly, stressful, and time-consuming. However, the highly specialized stator winder provides an even distribution and is commonly used in three-phase induction motors and other high-performance applications. The Industrial CNC Mills. In advanced metal factories like Voestalpine, the computer numerical control mills follow precise sets of instructions to drill or machine identical parts. The catch of this machine is its repetitive automation. The CNC mill enables manufacturers to fabricate parts from complex designs for clients across a diverse range of industries. Imagine when a machine can do what 10 engineers or blacksmiths would do in a shorter period. Milling is a very common type of metalwork. The rotary cutting tools involved in the milling process remove small pieces of material from the workpiece to shape the piece or create holes. Due to the CNC capabilities, these mills can model, manufacture, and analyze results faster to drive more efficient production. The machine is also very versatile. Milling works well on a variety of materials with varying degrees of hardness. The increased accuracy also means CNC mills can work on parts with different dimensions. The CNC mill can have up to 5-axis systems of control to mill workpieces from multiple simultaneous angles with different tools. This facilitates the fabrication of complex and precise milled parts at faster speeds than ever before. Due to advanced technology, CNC mills also follow designs down to the last detail. This ensures that products with multiple parts and layers can be assembled quickly and without error or misalignment. While all these factors are amazing, the most interesting factor of a CNC mill is its multifunctional ability. In one setup, a CNC mill can perform multiple operations, such as cutting, drilling, and shaping. Another feature of this advanced machine that blows the mind is the introduction of multiple axis milling. Before this groundbreaking technological innovation, the traditional mill could only manage 3 axes. But now the CNC milling machine allows the engineer to approach the workpiece from different angles, enabling the creation of intricate geometries and undercuts that would be impossible with simpler machines. Roku Magnetic Core Drill. The Roku magnetic drilling machine has a powerful motor with 1,200 watts, a speed regulator, a 2-speed gearbox, and clockwise or anti-clockwise rotation. Although there are other variations, the magnetic core drill is one of the most advanced in the world. This equipment is still a rare commodity. To be honest, how many times have you seen a production company boast of magnetic equipment in the West or around the world at large? The magnet of the Roku core drill has an adhesive force of 16,000 newtons, which ensures reliable attachment of the machine to metallic surfaces during the drilling process. The core drill drive is height adjustable and has a double dovetail guide, which ensures high stability and precision. The right-hand left-hand rotation, the 2-speed gearbox, as well as the precise adjustment of the speed, allow high flexibility in adapting to different drilling tasks. In addition, the machine offers better handling due to its small size and low weight of 16 kilograms. Core drills used for metalwork are called annular cutters. The core drill offers several advantages. It produces precise holes without causing significant damage to the workpiece. Like many other power tools, the ore drill comes in a variety of sizes and strengths to suit a variety of applications. Handheld core drills with tiny bits can be used around the house, but bigger, more powerful drills are utilized in large-scale construction, metalworks, or mining operations. Electric discharge machines, EDM. An electrical discharge machine is a highly advanced machine in manufacturing used to work on hard metals that are very difficult with other not-so-sophisticated machines. This type of machine follows a non-contact technique when dealing with the workpiece. It uses the principle of electrical discharges or sparks to remove material from a workpiece and cut and shape that material with high accuracy and unique surface finishes. The EDM machine is highly important when dealing with clients or industries with little or no margin for error. For instance, a client who wants car parts or airplane parts to be manufactured must give detailed specifications because even the slightest margin for error that is not given could cause a defect with the part. The electrical discharge machining working process is based on the generation of sparks and metal removal through spark erosion. EDM spark erosion is the same as when an electric spark strikes a piece of metal and burns a small hole into it. This process generates heat, which causes metal to be removed through erosion and evaporation. The EDM is a perfect advanced tool for the metalworking industry because it operates only when the workpiece and the tool are made of conductive materials. The EDM process does not require any human or mechanical force, making it suitable for machining brittle, delicate, or hard materials such as titanium, hardened steel, tungsten carbide, and conductive ceramics. This machine is highly accurate, with a tight margin for errors coming at only microns. It also provides an unbelievably neat surface finish, leaving the metal looking so good that it requires little or no polishing. Since the electrode does not physically contact the workpiece, there is no machine wear and tear. This means that the machine is not only highly effective, it is also durable. For the record, it is so dangerous that it would look good while taking your job and doing it to perfection. Water jet cutters. Not everything about the metal industry is about painful sparks and hardness. The water jet cutter is proof of high-level advancement in the metal manufacturing industry. It is an industrial tool capable of cutting a wide variety of materials using an extremely high-pressure jet of water, or a mixture of water and an abrasive substance. It is used to cut hard materials such as metal, stone, or glass. Water jet cutting is often used during the fabrication of machine parts. It is the preferred method when the materials being cut are sensitive to the high temperatures generated by other methods. Examples of such materials include plastic and aluminum. Every type of water jet follows the same principle of using high-pressure water focused into a beam by a nozzle. Most machines accomplish this by first running the water through a high-pressure pump. The water then travels along the high-pressure tubing to the nozzle of the water jet. In the nozzle, the water is focused into a thin beam by a jewel orifice. This beam of water is ejected from the nozzle, cutting through the material by spraying it with a jet speed of about 760 meters per second. An important benefit of the water jet is the ability to cut material without interfering with its inherent structure, as there is no heat-affected zone. Minimizing the effects of heat allows metals to be cut without warping, affecting tempers, or changing intrinsic properties. This means that sharp corners, bevels, pierce holes, and shapes with minimal inner radii are all possible. Water jet cutters are also capable of producing intricate cuts in material. Due to its relatively narrow curve, water jet cutting can reduce the amount of scrap material produced by allowing uncut parts to be nested more closely together than traditional cutting methods. These machines are highly beneficial, but they are gradually replacing humans, and soon enough, there will be no jobs for engineers, blacksmiths, or technicians. Materials commonly cut with a water jet include textiles, rubber, foam, plastics, leather, composites, stone, tile, glass, metals, food, paper, and much more. CNC Plasma Cutters. CNC plasma cutters operate by forcing gas or compressed air at high speeds through a nozzle. Once an electric arc is introduced to the gas, ionized gas or plasma is created, the fourth state of matter. It, in turn, cuts through the metal. This complex shape-cutting ability is achieved by generating high-temperature plasma, which melts through the conductive metal, while a drive system moves the plasma torch around the plate to trace out the required shape. In other words, the parts are held in shape while the cutting tool moves around the surface of the parts. The plasma used throughout this process is ionized gas. The ionized gas becomes energized and overcomes a threshold where electrons escape from their atoms, but still manage to attach to the nucleus, creating plasma. This plasma then flows down the cutting head and out of a nozzle. The arc follows the path of the plasma until it contacts the base metal. This allows the electric circuit to complete, and a constant arc is maintained, which ionizes new gas as it is fed through the nozzle. This is a highly advanced machine that is not only accurate but very quick. Depending on the thickness and material of what is being cut, the machine can run at speeds of up to 500 inches per minute. A plasma cutter containing a plasma torch that can reach up to 40,000 degrees Fahrenheit. At that temperature, most materials cannot withstand the heat, including metal, causing the material to bend to a precise cut. A very interesting fact about plasma cutters is that there are different gases for different metals and different qualities of cut. Robotic welding machine. A welding robot is an industrial machine programmed by a technician that can carry out electrical welding work fully autonomously. They simulate the movements of a human arm. These robot machines can perform repetitive functions with great precision and speed. Since robots can simulate the human arm, they can easily replace human existence in the workplace. For instance, in the automotive sector, robotic welding generates higher performance due to repetitive and long-term productions. Robotic welding has become increasingly popular because of its mostly human-independent process. The most commonplace robotic welding machinery is made up of two main components. The mechanical unit creates manipulations in the material or parts to create the component or product, and the controller is considered the unit's brain in that it is what makes the arms of the unit move based on a design implemented into the system. The movements of the unit can either be pre-programmed or guided by machine vision, which is an imaging-based automatic inspection and analysis technology. Although it can be beneficial to the manufacturer, welding has traditionally always been done manually, which implies a greater number of workers. But over the last few years, a dangerous revolution in the industrial sector has seen many huge manufacturing companies replace humans with robots. The only current job of professional welders is to supervise the quality of the robots while they are in charge of carrying out the repetitive processes that lack great value. Robotic machines adapt to any work position and working conditions, and they don't get tired of doing repetitive jobs. For instance, robotic welding systems can produce 24 hours a day, allowing for greater productivity and throughput. Robotic welding assists both manufacturers and the customer in creating more efficient processes, while automation is the way of the supply chain future. It decreases long-term costs, provides labor and machinery utilization stability, increases productivity, reduces error rates and frequency of inventory checks, and optimizes the component picking and sorting process. The CNC Press Break. The CNC Press Break machine is one tool without which the manufacturing industry and fabricators will not be able to make any progress. It is a normal press bake with the sophistication of a computer numerical control integrated into it. With the help of the CNC system, the machine can efficiently bend and manipulate metal sheets, be it over a few millimeters or a few meters long, and there are no restrictions on the shape and design of the result. A CNC press brake machine is a mechanical tool powered by a hydraulic or electrical system, with an AI program attached to it for precise and accurate bending of the raw material. Before using this machine, you enter a program detailing specifications about your results, down to the angles. Then, you wait for the computer to process and start working on your job. The machine works with the help of hydraulic or electric force, either a hydraulic press brake or an electric press brake. Depending on the type of your machine, the force will be applied to the respective moving part of the machine. This allows the moving part to press the metal sheet against the fixed part, thus creating the desired bend. The machine will move the metal sheet according to the instructions needed in the computer. Technology has been quickly upgrading traditional tools into powerful and reliable ones fit for the modern era. The same applies to CNC Press Break machines. It is automated and does not require human or manual interruptions. This allows for things to flow smoothly and to continue a better workflow, thus increasing efficiency and productivity. The press bake machines are also easy to maintain, cause less wastage, and have top-grade components and parts that are easily available if they break down. Since the CNC press bake is a long-term investment, manufacturers must be sure they want to bend metal long-term before purchasing it. If your designs are too complicated, you need to consider buying a machine with an extra axis so that your bends turn out flawless, like the extra axis in a CNC milling machine. Also, consider the quantity in which you will be producing materials. If you are considering mass production, CNC press brake machines are the ideal choice. 3D metal printer. A metal 3D printer is a device that shapes metal materials such as titanium, aluminum, and stainless steel, based on 3D CAD data. In general, 3D printers using resin as a modeling material are widely used in industry, but the current situation is that few companies have introduced expensive metal 3D printers. Unlike the cutting process, which shaves a lump of metal, or the forging process, which molds it under pressure, metal 3D printers are designed to layer and develop metal materials to handle complex shapes such as mesh structures and hollow designs. 3D printers for metal have advantages over conventional processing methods, such as cutting, casting, and forging. While there is still room for improvement, they can print metal parts with excellent strength and durability. They can also produce prototypes easily to reduce costs. With 3D printers for metal, materials can be stacked and shaped, so even complex shapes that are difficult to cut can be produced. When cutting, it is difficult to install a cooling water pipe inside the mold, as there is a limit to the area that can be cut by the tool. However, 3D metal printers can mold even hollow structures and produce products that cannot be made with conventional machining. If the product has a complicated shape and cannot be manufactured, or if you want to process materials that are difficult to cut, it is better to use a 3D printer for metal. In addition, for products requiring multiple cutting processes, using a 3D metal printer can shorten the production process and produce them quickly. If you also want to prevent material loss, it is a good idea to use a metal 3D printer. This is because there is a loss of material during the cutting process due to the removal of the resulting chips. The spectacular TrueLaser 3030. The advanced TrueLaser 3030 fiber is a CNC laser cutting machine that is also one of the fastest machines for cutting tasks. This machine works on the principle that a focused high-power laser is used to cut, inscribe, or engrave a metal surface to get the desired shape. The TrueDisc solid-state laser enables the processing of non-ferrous metals and provides the manufacturer with a productivity benefit in thick and thin sheets. Brightline fiber guarantees the highest edge quality and facilitates part removal. The CNC Laser Cutter works on the principle of a non-contact thermal process. It features a laser head containing a laser focusing lens and a nozzle. Through the nozzle, this head and lens assembly focus a laser beam, a column of very high-intensity light on the workpiece, melting and cutting the workpiece to form the desired shape. CNC lasers employ compressed gas, also flowing through the nozzle that ejects the laser beam to cool the focusing lens and expel the vaporized metal out of the workpiece. To understand better, imagine a scene when you focus a high-powered laser beam at a point on a metallic surface. The heat density at that point becomes high, resulting in rapid heating and partial or complete vaporization of that point on the metal. Then, the CNC technology controls the sequence of movements of this laser head and laser beam on the work surface to form the desired custom shapes and features. The CNC fiber laser cutter, like the True 3030 laser in particular, uses a bank of diodes to create the beam, which is focused through a fiber optic cable. Although fiber lasers are compatible with a broad range of materials, you must pay special attention to silver. Silver retains heat from the laser and starts to warp during cutting operations, making it challenging to achieve the desired machined part. As a result, top-tier machine shops typically use a bracket as a heat sink to transfer heat away from the silver workpiece during fiber laser cutting operations. The non-contact nature of the laser cutting process decreases the risk of material distortion and material contamination, making them ideal for machining components that will be used in the medical industry. Technology is evolving at an alarming rate. It makes you wonder if the next generation would struggle with having jobs. Advanced hydroforming machines. An advanced hydroforming machine is used to shape ductile metals such as aluminum, brass, low-alloy steel, and stainless steel into lightweight, structurally stiff, and strong pieces. It is used in a specialized type of die forming that uses a high-pressure hydraulic fluid to press room-temperature working material into a die. Hydroforming allows complex shapes with concavities to be formed, which would be difficult or impossible with standard solid die stamping. Virtually all metals capable of cold forming can be hydroformed, including aluminum, brass, carbon and stainless steel, and copper. The metal tube or sheet is placed on a die, and fluid pressure is applied. This forces the metal to assume the shape of the die cavity. There are two types of hydroforming. For the sheet hydroforming process, a metal sheet and only one die, the cavity or punch is used. Hydraulic pressurized fluid presses against the metal sheet, forcing it to adopt the contour of the cavity. Whereas in the tube fluid forming method, the tube metal is positioned between two dies, and hydraulic pressure is forced into the tube. This pressure pushes the tube outwards, forcing it into the die cavity, assuming its shape. Hydroforming machines are ideal for forming complex metal parts with irregular patterns and contours. They do not need welding of two halves like in old methods, ensuring that the resulting shapes have smooth surface finishing. The automotive industry has benefited a great deal from hydroforming. Manufacturers can use the sheet hydroforming process to fabricate automotive parts, line panels, brake pads, engine shields, gas tanks, and so on. A vibratory finishing machine. In its simplest terms, a vibratory finishing machine uses vibration to smooth out a surface. It can be used on a variety of materials, including metal, plastic, and wood. It has a greater tendency to produce a smooth finish, which is ideal for reducing the likelihood of future problems like rust or corrosion. A vibratory finishing machine works by vibrating the bowl that contains the tumbling media and the parts to be finished. The bowl is mounted on a base that is equipped with a motor or other vibrating mechanism, which causes the chamber to vibrate. As the bowl vibrates, the tumbling media and the parts inside the chamber move and bowl against each other, which helps to smooth and polish the surface of the parts. The intensity and frequency of the vibratory action can be adjusted to achieve the desired level of finish. The duration of the finishing process can also be controlled, depending on the desired level of finish and the type of parts being processed. Vibratory finishing machines are versatile and efficient, capable of high-volume production and producing uniform, high-quality finishes. They are commonly used in the automotive, aerospace, and medical industries. They can be used to deburr, deflash, and polish a wide range of parts, including castings, forgings, and machined components. Vibratory finishing machines can also be used to remove rust, scale, and other surface contaminants, and to improve the surface finish of parts. In addition to the vibratory action, the finishing process can also be aided by the use of a liquid or compound, such as a detergent or rust inhibitor, which can help remove contaminants and improve the surface finish of the parts. The liquid is typically added to the chamber along with the tumbling media and the parts, and it helps to lubricate and cool the parts as they are finished. In general, vibratory finishing machines tend to be more cost-effective than other finishing methods, such as hand finishing or abrasive blasting, especially for high-volume production runs. However, the question remains, how many production plants can afford it? CNC grinding machines. CNC grinding machines are machine tools that use a rotating grinding wheel to achieve material removal on a metallic workpiece using cutting. Grinding machines are mostly used for the hard fine machining of workpieces, parts. The surface quality that can be achieved is very high, and grinding machines thus almost always find application in modern industry as a finishing process. Since the early beginnings of grinding, possibilities have been sought for carrying out this machining process within ever shorter timeframes at a satisfactory level of quality. The most high-tech type of grinding machines today are the ultra-modern CNC grinding machines. Even with the most complex of part geometries, such as crankshafts, camshafts, valves, ball bearings, or transmission shafts, it is standard today to achieve reliable, fast, and automatic machining with CNC machines. Besides the high machining performance possible with today's CNC grinding machines during the actual grinding process, the loading and unloading of the workpieces is often also carried out fully automatically using automated loading facilities. So, for the machining process itself, the continual presence of a worker at the CNC grinding machine is no longer necessary. Thanks for watching. See you in the next video.